Hey guys, hi, welcome back. So in this video, we will discuss the questions of CSI Net, and all the questions are of solid state physics. So we will do for the June 2011 and December 2011. Okay. So we will start here with the first question, and I would like to say this is the most requested video because many of the students wanted me to upload the videos related to the previous year questions, and solid state was requested by many of the students. So I'm starting with solid state physics. Okay. So let's see the first question here. So what it is said here, a narrow beam of X-rays with wavelength 1.5 Armstrong is reflected from an ionic crystal with an FCC lattice structure with a density of 3.32 gram centimeter cube inverse. So the molecular weight is 108 atomic mass unit, and 1 atomic mass unit is equals to, it's given. So you will have to calculate the lattice constant. So the question is quite simple. Here you are given a narrow beam of X-rays and the wavelength lambda. Okay, it is given to you 1.5 Armstrong, right? So it is reflected from a ionic crystal, and it is reflected with what? FCC lattice, okay, face center cubic lattice. So the structure, cubic lattice structure, and the density is given to you 3.32 gram centimeter cube inverse, and the molecular weight is also given to you. So you will have to calculate the lattice constant, or you can say the lattice parameter. Okay, so this is very obvious and very clear. If you know the relationship between the lattice parameter and the density, okay, mass density, then with that you can calculate. Okay, since the lectures is not done, so directly I will use the formula. Okay, so if you are having any problem, you can just go and see the lattice parameter and the relationship between density of cubic crystal. So there we used to write A is equals to what? Okay, we used to write the lattice parameter A, it is equals to N effective. Okay, this is the number of atoms per unit cell. All right, and this is M, this is the molecular weight divided by, you are doing with the Avogadro's number, right? And rho, this is the mass density. This is whole to the power 1 by 3. Okay, so I'm writing A cube is equals to this, because we are asked to calculate the value of what? Lattice constant. So for this directly you can write, we know for FCC lattice the number of effective atoms. Okay, number of atoms per unit cell, and effective is 4, right? This is directly I'm putting the values because we are not studying the theory, because if I go on explaining how N effective is 4 for FCC, it will become a very lengthy video. So directly I'm doing just for the students who wants previous year questions. All right, and these things I will explain in the lectures later on when I will start the solid state physics lecture. So this N effective is 4 here. Okay, and the molecular weight, it is given to you 108. All right, the density is given to you, rho is equals to 3.32 gram centimeter cube inverse. So this is not that tough, you can convert it on your own. Clear? So this is what it is. Now we will put the values directly in this, and before that we will write the Avogadro's numbers value. Na, it is equals to what? 6.023 into it 10 to the power 23, right? This is the value. So directly when you will put these values in this formula, A cube is equals to what? 4 into with 108, this entire term divided by what? Here you're having Avogadro's number 6.023 into 10 to the power 23, right? Rho is 3320. Okay, so when you will calculate this value, you will get the answer to be 6 Armstrong. Okay, you can do the calculation on your own. You know 1 Armstrong is what? 10 to the power minus 10, right, meter, and that way you can calculate. So this is option A. Calculation part I'm not doing because it will take much time and I need to cover all the year papers. Okay, next let us see question number 2. So here it is said the sine of the angle corresponding to 111 reflection is what? So you are just asked to calculate the sine of the angle. So for this, what you will use? You will use the Brake's law. What it is? According to Brake's law, you can write it as what? 2d sine theta is equals to lambda, right? Now you see here, d is equals to what? A by root over h square plus k square plus l square. this HKL, this is H, this is K, and this is L. Okay, this is the interplanar distance. Okay, interplanar distance. I think these things are clear. These things you have studied when you have done the lectures part. Okay, so interplanar, these are the HKL, these are the Miller indices. Okay, interplanar spacing. These things are very easy. If you're having any problem, just go to the book, any book for solid state physics. There you can see if you're having problem with the formulas. All right, so for here, for this, you have calculated A to be 6 Armstrong. So this will be 6 divided by √3. Just put the values of H, K, and L. All right. Now you see, lambda was given to you. Lambda was 1.5 Armstrong. Right. So from here, when you will see sine theta, okay, it is equals to what? Lambda by 2D. Okay. So lambda is 1.5 divided by 2. Your D is what? 6 by √3. So this you can write 15 by 10. I'm just writing 1.5 as 15 by 10. This is 2. This is 6. I'm writing 2 into 3. In the numerator, it's √3. So 5 what? 5 3s are 5 2s are. This 3 will cancel this 3, and you will have √3 by 8. Done. So the correct option is option B. Okay. So here the second question is what? A flux, okay, quantum fluxoid is approximately equal to 2 into 10 to the power minus 7 pi into 10 to the power 5 Gauss. So you are having a fluxoid here. Okay, and the value of the fluxoid that is given to you, that is, this is phi naught. Okay, now you see it here, what it is said, a type 2 superconductor. It is placed in a small magnetic field. Okay, and when this magnetic field will increase till the time it is penetrated, till the time it will start penetrating the superconductor. Now here the strength of the field is given to you. That means this field is what? The first critical field. Okay, the value of HC1, the value is given to you. So directly the first question is asking you to calculate what? The penetration depth of the superconductor. So where, if you have studied the superconductivity, there you know the penetration depth. Okay, London penetration depth, it is denoted by lambda. Okay, and you have a relationship between this first critical field and the London penetration depth. Okay, so here you will see HC1. Okay, it is equals to what? Phi naught by this one. Okay, phi naught by pi lambda square. From here you can rearrange and calculate the value of lambda to be what? Phi naught by pi into it HC1. Okay, so this is for type 2, and one more formula you will have for the coherence length. Okay, that is also same. Here instead of lambda you will have xi. Okay, and this will be what? This will be AC2. Okay, the second critical field. And always remember, for type 2 superconductor, what it will happy, xi will be what? Less than lambda. These are things we can study in the theory part. Just for a brief I'm giving you. So here directly we can put the values. You are having this to be what? So I'm writing here once what is given to us. HC, sorry, this is AC1 is equals to what? 2 by pi into 10 to the power 5 Gauss. Okay, so here phi naught, okay, it is equals to 2 into 10 to the power minus 7 Gauss per centimeter square. Okay, so finally you will write lambda square is equals to what? Phi naught is 2 into 10 to the power minus 7, right? And here you're having what? Pi into it, 2 by pi into 10 to the power 5. So this pi and pi will get cancelled. This 2 and 2 will get cancelled, right? And here if you see, the in case of units also, here you have a Gauss per centimeter square. Okay, these things you can do on your own. Okay, I think that this unit part is very clear. You don't have to think so much about the unit part. Okay, so directly when you will do this, you will get it to be what? 10 to the power minus 12, right? 7 plus 5 minus 7 minus 5. So add 7 plus 5, so it is 12. Negative sign will be there. Okay, so this will give you what? Lambda is equals to what you will write in this case? It is 10 to the power minus 12. You can do the entire calculation on your own. This will be what? 10 to the power minus 6. This will be centimeter. This was centimeter square. You can see Gauss will get cancelled and you will have centimeter. So from here, lambda is equals to -6 centimeters. So convert it into meter, and then you can go to Armstrong. When you will do so, you will get this value to be 100 Armstrong. Okay, calculation part I'm not doing. I think this is very, you can change the units and get your answer. Okay, so the correct option is option A. And then directly you can do, this is what, centimeter, na? This is 10 to the power -6 centimeters. So when you will convert it into meter, you will write what, 100. Again, then when you will do so, you will get it to be what, 10 to the power -8, right? So then you will have to convert into Armstrong, and these things you can do. So 10 to the power -8 into it, you will do what? You will directly just write 1 Armstrong is what, 10 to the power -10. So when you will do so, you will just divide by 10 to the power -10, 10 to the power -10. So this will give you what, 10 square, right? So it is what, 100 Armstrong. Clear? So this is how you can do the calculation. I'm not going into the details. Okay, now let us see question number B. So here it said the applied field is now further increased till superconductivity is completely destroyed. Okay, the field of the strength of the field is given to you 8 by pi into 10 to the power 5 Gauss. So you're asked to calculate the correlation length. Just now we have seen the relationship between what? The correlation length or coherence length. We wrote it to be equals to, just now we have seen, directly can rearrange and write xi square is equals to what? Phi naught by pi into with 8c2. This is the second critical field, and this is denoting the second critical field here. So directly you will put the values. Xi square is equals to phi naught, already it was given 2 into 10 to the power -7. Okay, Gauss per centimeter square. So directly when you will put 2 into 10 to the power -7, okay, divided by pi into 8 by pi into 10 to the power 5. Okay, so pi and pi get cancelled. This is 2 4s. So finally we get 1 by 4 into 10 to the power -12 centimeter square. So xi is equals to 1 by 2 into 10 to the power -6 centimeter. Okay, convert into meters, we will get 1 by 2 into 10 to the power -8 meter. Convert it to Armstrong. So you will get it to be what? You will get here 100 by 2. You can do and see, this is 10 to the power -10. Okay, plus 2 minus 2. Okay, to the power of 10. This will give you 50. Okay, so finally this is 50 into 10 to the power -10 meter. So which is equals to what? 50 Armstrong. Then if you see the question, none of the option was matching. Okay, because all the options are different than 50 Armstrong. So your answer is 50 Armstrong here. Okay. So here in the question, like I said, a two-dimensional lattice of graphene, okay, is an arrangement of carbon atoms forming a honeycomb lattice of lattice spacing A, as shown below. So the carbon atoms occupy the vertices. So yeah, what it is said in question number A, the Wigner-Seitz cell has an area of what? Okay, the area you are asked to calculate. So let us see the question again. So here it is said you are having a two-dimensional lattice of graphene, and it is arrangement of what? Carbon atoms, and it is forming a honeycomb. Okay, lattice spacing is A. Figure is given to you. Carbon atoms are occupying the vertices. Okay, we already know what is Wigner-Seitz cell. The Wigner-Seitz cell is the Wigner-Seitz cell is what? Which is containing one lattice point. Okay, so directly you can write that the volume of the Wigner-Seitz cell, it is equals to the volume of what? Any normal cell divided by the number of lattice points of the normal cell. So here if you see, in this case, area of Wigner cell, we will write what? Area of normal cell divided by n, right? Number of lattice point in a normal cell. So you see here, normal cell is what? It is a hexagon, right? And you can directly write the area of hexagon and the number of lattice points. That way also you can calculate. So when you will do so, you will get directly the answer to be what? 3√3 a square by 2. Okay, because we know the area of hexagon formula. So directly you can do. Okay, when you will write in that particular way, because number of lattice points, and you can write 6 sides into with 1 by 3, then you will get 2. These things I'm not doing. So this is how you can calculate. But one other way to calculate the area is the normal way. Okay, so that we will do, and we will approach by finding the value of B1 and B2, and then we will take the cross product. Okay, and there are some calculation which I will skip because that will make it very lengthy. All right. So first from this we will see which is the primitive lattice vector. Okay, so here if you see from the figure, the primitive lattice vectors are B1 and B2, right? So when you will resolve the vectors and you will write the value of B1, then you will write what? You will write here √3a will be outside, right? Here you will write cos. Okay, so if you see here what will be the angle? Cos 30 degree. How it is 30 degree? We know the angle between two sides of hexagon is 130. Okay, this entire angle is what? 130. When you will resolve this, okay, in this way, this entire is 130. Okay, I'm taking this imaginary line. Okay, so this will be 60. Okay, so half of it will be what? 4 times, it is dividing it 4 times now. 1, 2, 3, 4. Okay, so one side is what? 30. This angle is what? 30 degree. Just take and see, if you're taking a hexagon this way. Okay, and I'm taking this as an imaginary line. Okay, this is B1. So when you will resolve one this side and the other one, you will resolve this side. Okay, this is Y, this is X. Means this is I cap, this is J cap. So this angle you need. Okay, because you are resolving this side and that side. This will give you cos and this will give you sine. This is how you do for vectors. So when you will do so, this is cos theta. Here theta is what? This entire angle is 120. The half of it will be what? 60, and then its half will be what? 30. So this is what? Cos 30 degree plus, okay, and this cos 30 degree will have a I cap. Okay, plus you are having here what? Sine 30 degree. Right, this is what you will have. Now this sine, when you will convert into what? Cos, then you can directly write, you know what? Sine 90 degree minus theta. Right, so sine 90 degree minus 30 degree, so it is will become cos 60 degree. Right, this is how you write. So it will give you what? Root 3a cos. Right, this is j cap here. Cos 30 degree I cap plus cos 60 degree I cap. Okay, root 3 by 2 will be there, a, because this is cos 30 degree value is what? Root 3 by 2. Okay, so this is root 3 I cap, 2 I'm taking outside, plus, and this is cos 60 degree, it is 1 by 2. Okay, so you will have just j cap. Now you see, when you will calculate B2, so it will be same but with a negative side, because this side you will have minus j cap. Now when you will resolve B2, one is this side, other one is this side. So directly you can write root 3 by 2 a root 3 I cap minus j cap. If you are having a good knowledge of vectors, you will not have any problem. So if you are having any problem, just go and see the entire vector chapter. Okay, and finally we write what? B2 cross B1 to calculate its area. Okay, so when you will do this B2 cross B1, this is B1, this is B2, just do the cross product and you will get the answer to be 3 root 3 a square by 2. Okay, or also regular hexagon things I have seen you. You are having any problem, just go and see the regular hexagon area. You get in any of the intermediate books. Done. Next, let us see. Here it is said the Brevis lattice for this array is what? So it's very clear the Brevis lattice will be what? In this case, the Brevis lattice for this array is the what? It is the hexagonal lattice, right? With basis vectors what? A1 and A2. So these are very easy questions. If you are having all the definitions very clear, what is basis vectors, what is primitive lattice vectors, then if you know, you can see a separate lecture of any YouTube channel, or just you can go to any book and see the honeycomb primitive lattice vectors. There it is clearly explained. Okay, if I will do this in this video, it will become very lengthy. So next you see question number 4. So here it is said the potential of a diatomic molecule as a function of the distance r between the atoms is given by potential V is equals to minus a by r to the power 6 plus b by r to the power 12. So potential V is given to you. Okay, this is for a diatomic molecule and it is a function of r. So you will have to calculate the value of the potential at equilibrium separation between the atoms. So for equilibrium, what you are writing, you already know. At equilibrium, what? dV dr. Okay, that r equals to r naught is equals to 0. So potential is here. Just differentiate here. What you will get when you will do the differentiation in this case, you will get a, right, divided by, this is 6 r naught. I am writing this because r is equals to r naught to the power 7. Right, this is what you are having. This will give you minus, this is 12 b r naught to the power 13 equals to 0. So just you can write 6a by r naught to the power 7. It is equals to 12 b by r naught to the power 13. This is 6 2s are 12, right? So r naught to the power 13 by r naught to the power 7. It will give you 2b by a. So when you will do this, you will get this to be r naught to the power 6 is equals to what? 2b by a. Now directly this value will put in this potential. Okay, and you will get the value of the potential at equilibrium separation between the atoms.
So V R naught this time. It is equals to what? Minus A R naught to the power 6. R is equals to what? R naught. So this value will be what? A by 2B reverse, right? And here you are having what? Plus B. R naught to the power R to the power 12. So it will be what? A by 2B whole square. So this is minus A square by 2B plus this will give you what? A square, right? And this is what? 4B. B and B will get cancelled. And when you will do so, you will get this to be 4B. And this will give you minus 2A square plus A square. So minus A square by 4B. Okay, this is the answer. So the correct option is option A. Not option A. Minus A square by 4B. So option D. Done. So this is very simple. Next, let us see question number 5. Here it is said if the number density of a free electron gas in 3 dimension is increased by 8 times, its Fermi temperature will increase or decrease by a factor of 4 or increase or decrease by a factor 8. So number density of a free electron in 3 dimension. Okay, this is what you asked. Okay, number density is of a free electron gas in 3 dimension. It is increased by 8 times. Okay, so if you know the relationship between the first, you see number density is given to you. So first you will write what? The Fermi energy, EF, right? So the formula of EF, I think you have studied in the theory part also what the formula. You know EF is directly proportional to the Fermi energy, is directly proportional to the Fermi temperature. Okay, there is a constant, but we are ignoring the constant. Just we need to calculate the increase and decreasing factors. Na? So if you know the Fermi energy formula, directly you can write here what? EF. Okay, EF is equals to what? It is equals to h cut square by 2m 3 pi square n 2 by 3. This is for 3 dimension. Okay, so now you see in this case EF is equals to number density is denoted by what? And now it is increased by what? 8 times. So if I write h cut square by n 3 pi square 8n 2 by 3. Okay, this I'm noting by EF prime. Okay, because increased one we are writing. This is EF and this I'm denoting by EF prime. So here you see h cut square by 2 pi 2m. This 8 I'm taking it outside to the power 2 by 3. This is 3 pi square and to the power 2 by 3. So you can write here h cut square by 2m 3 pi square n to the power 2 by 3, and this will 2 cube, so it will be 2 square. So 4, right? Now if you see this term, this is what? EF and this is 4. Now you see what you have seen, the Fermi energy is increased by 4 times, right? And if you see the relationship between the Fermi energy and the temperature, it is directly proportional to the Fermi temperature. So if the Fermi energy is increasing by what? 4 times, when the number density of a free electron gas it is increasing by 8 times, then the temperature will also decrease by what? 4 times. Okay, by a factor 4. So directly what you will write? The Fermi temperature will increase by a factor 4. Done. So now let us see the last question. Here it says the excitation of a 3-dimensional solid are bosonic in nature with their frequency omega and wave number k are related by omega is proportional to k square in the large wavelength limit. If the chemical potential is 0, the behavior of the specific heat means CV, of the system at low temperature is proportional to what? So if you have studied the Debye theory and then the density of states, from there directly you can get this. Okay, so if you have seen this, the proportionality, it's all about the proportionality here. For larger limit, okay, it is given to you omega is proportional to k square. Okay, we know omega is proportional to k to the power n. Okay, for large limit. So if omega is proportional to k to the power n for large limit, then specific is proportional to what? Specific is proportional to t to the power what? D by n, you can say. D is the dimension. Okay, so it is d by n. Directly you can see from here. So if you see in this case, omega is proportional to what? K to the power 2. So CV is proportional to what it will be? D is already 3. So 3 by 2. Okay, so directly you can write the specific heat is proportional to what? 3 by 2. So the correct option is option C. Done. You can see this density of states and these things. Now here, you know, G omega is proportional to what? K square. Okay, that way you can write G omega is proportional to K square, CV is proportional to T to the power D by N, and all these things. Okay.
Just have the basic knowledge and you can solve the questions very easily. Okay, and this you remember, this is for low temperature. For high temperature it will be different, and the conditions you need to keep in mind. Okay, so that's all in this video. Thank you so much. Have a good day.